Welcome back to Chem 101. In this video, I'm going to show you how to calculate the molecular formula mass of a compound.
We are going to calculate the molecular formula mass, or as it's sometimes known, the molar mass of a compound. So let's start with something easy. Something like sodium chloride. Now we're going to need to know what the periodic table values for both of these elements are. And from the periodic table we can see that sodium has a molar mass of 22.9898 grams per mole. Now that's for sodium. And chlorine is 35.453 grams per mole. So using this information, we can now work on our molar mass. So there's a formula for molar mass where the molar mass is equal to the first atom, or the mass of the first atom. So we'll say mass of atom 1. And then we have some number that we're going to multiply by that, because there might be more than one of that particular atom. And we'll just add that to now the mass of atom number 2. And in our case, for sodium chloride, there's only 2 atoms. And then again, there'd be a number here if there was more than one atom. So we can fill in these values now. So our molar mass is going to be equal to the mass of, in this case, I erased our molecule, sodium chloride. So for sodium, that'll be 22.9898. And since there's only one, we're just going to be multiplying that by 1. And we also have one chlorine atom, and that has a mass of 35.453. I left the units off. These are grams per mole, so our molar mass in the end will be grams per mole. And so the answer comes out to 58.4428 grams per mole. Okay, let's do a different one. Let's do one that has a few more atoms in it. How about carbon with 2 fluorines and 2 chlorines. So CF2Cl2. So we need to go to our periodic table. We're looking for chlorine, fluorine, and carbon. So we're going to say carbon is 12.0107 grams per mole. Fluorine 18.9984 grams per mole. And we did chlorine already, but 35.453 grams per mole. So we need these 3 values off the periodic table. Alright, so our molar mass will be equal to, our first atom is carbon, and there's only one, so it's 1 times 12.0107 plus, now we have 2 fluorines, so it's going to be 2 times 18.9984 and 2 chlorines, 35.453. Again, the units are grams per mole, and our answer comes out to be 120.9135 grams per mole. Let's try one that's a little more complicated, maybe that has a few more atoms in it. Something like, let's do NH4 2 SO4. So this will be ammonium sulfate. Alright, so we need the molar mass of hydrogen, molar mass of nitrogen, oxygen, and sulfur for this one. So our first atom, let's say it's nitrogen. We got to figure out how many there are. And in this one, there are 2 ammonia molecules, 2 of them. indicated by the subscript 2 here. So that tells us that we have not only 2 nitrogens, but 4 times 2, or 8 hydrogens. So nitrogen, we have 2, so it's 2 times 14.0067. We have 8 hydrogens, so 8 times 1.00794 plus 1 sulfur, so 1 times 32065, and plus, now we have 4 oxygens, so 4 times 15.999. So the answer for this molecular formula mass would be 132.13, let's say 80 grams per mole. Alright, so that's how you calculate formula mass. Now in the next video, we're going to look at mass percent, or as it's sometimes known, percent composition.